Question number 31. A boat is made of metal, floats in water with 1/5 of its volume submerged. If a second beat second boat should be second boat is made with the volume three times, not 3 times, it is 3 times than the first, using the same mass of the same material, same metal that has used to construct the float boat. In the ratio, the maximum load that can be carried by second boat, the maximum load that can be carried by float boat. For the first boat, I will consider total volume V. Then V rho G upthrust, total upthrust, should be equals to, for the first boat, I will consider volume as 5V. It is easy to get simplification. For the second boat, total volume is 15V. It is 3 times the first boat. There is the same mass. Then 1/5 of first boat is immersed in water. Then immersed portion is 1/5V. It means 1V, 1/5 of total volume. This one is the total volume. Then unimmersed portion is 4V. We can get maximum load m1g plus mass of the boat mg should be equals to 5V rho g. For this one, maximum load m2 plus same mass for the boat mg, same mass of same material, should be equals to 15V rho g. Now we have to get M1 ratio between M1g and M2g. Then I will cancel out M. No. We can use mg. Mg is given by this immersed portion, V rho g, 5V rho g. Again we can get m1g equals 4V rho g. For this situation, we can get same mass, therefore V rho g, same upthrust, 15V rho g. We can get same equation. M2g should be equals to 14V rho g. When dividing both the equations, we can get that M2 divided by M1 is 14/4, 7/2, 3.5. Then there is no the correct answer for the question number 31. Then 32, a thin-walled cylindrical vessel is floating in a lake. At time t equals 0, a small hole is made at the bottom of the vessel, and water is allowed to flow into the vessel at the constant rate so that the vessel immerses with constant velocity. If h1 is the difference of height of water level inside and outside vessel tank, h2 is the height of the beam above the outside. Water level at time t. Which of the following curves best represent the variation of the height h1 and h2 with t until vessel is fully immersed? h2 is the outer height, It is decreasing with time uniformly, like this. H2. It is the outer height. When immersed in object, this height is no. When immersed in the system by filling water, the object is floating. Therefore, this H1 height should be constant. H1 should be constant. But when immersing object, when fully immersing, water will flow by the brim of the container. Therefore, when fully immersed, it means H1 0. H1 is the difference of height in water level inside and outside the vessel. H1 is this one, not this one. H1 is this one. It should be like this, constant and decreasing up to 0 when fully immersing. Now H2 is this one. When immersing object, H2 is decreasing with time, like this. H2. Then answer is 2 for the question number 32. 33. Water in the tank is uniformly bubbled with a small identical air bubble, each having volume V0 as shown in the figure. A sphere of mass M and volume V floats in water as shown due to the attachment of certain number of air bubbles on its surface. If dW is density of water and the minimum number of air bubbles that need to be attached to keep the sphere floating in water is N, then we have to get N value. This is the sphere. Its mass capital M should be equal to upthrust for floating. Then we can get the equilibrium. Weight should be equal to upthrust. We know that it is floating principle. mg equals, when getting upthrust, we have to consider volume of sphere and volume of air bubble. Volume of one air bubble is V0. Now there are n number of air bubbles. It is volume, total volume of this sphere. Density of water is given as dW G. Now we can subject in value. mg divided by dW G. G is cancelling. mg divided by dW minus V equals V0 N. Now we can subject in m divided by dW V0 minus V0 divided by V0. dW V0 m minus dW V0. No, this one is V, dW V. Now, we know that when considering this situation, I have considered that there is no mass for air bubbles, but for the actual situation, there is a mass for air bubbles. Therefore, mass of this total system, capital M sphere and sum of air bubbles should be greater than this value, capital M value. Therefore, total mass is increasing for the actual situation. Therefore, upthrust should greater than this value. It means N value should be greater than this one. The second one is the correct answer. If you are considering equal, it is false. They have not given density of air bubbles or density of air medium or mass of air bubbles. But we know that there is a small weight, small mass for air bubbles. Question number 34. A cube of wood is floating in a beaker of water as shown in the figure. At time t equals 0, the beaker begins to move the downward direction from rest with constant acceleration. The variation of volume V of the portion of the cube that is immersed in water. This time t is best represented by. Now we have to consider the variation of volume of the portion of the cube that immersed in water. There is a constant acceleration. Therefore, the resultant force should be constant for the system. Then there is a constant value of upthrust. It means it is constant. Immersed volume is constant because of upthrust is constant. In 35, then answer 1 for the question number 34. 35. An empty thin-walled container of volume V and mass M0 is filled with a number of glass and steel balls, out of which X are glass balls if MS and Mg are masses of steel and glass balls respectively. Then the effective density of container balls would be. There is a small problem. In first sentence, thin-walled container of volume V and mass M0 is filled with n number of glass and steel balls. N number of. It should be changed. Out of which X are glass balls. There are simple n number of balls. N number of balls. Out of n number of balls, X are glass balls. Then n minus X are metal balls, steel balls. We have to get the total volume. Now, volume of the container is V. It is the total volume of the system. Then we can get density equals to mass divided by volume. Mass is given by 3 components of the system. First one is metal balls. We can get mass of metal balls, mass of a steel ball MS times number of balls in minus X. Second one is glass balls. Mass of a glass ball Mg into X number of glass balls. Plus mass of empty container M0. This is the total mass. We have to divide by total volume V. Then this one is the correct answer for question number 35. 36. The figure shows the gas apparatus used to compare the densities of two liquids A and B. If the same experience is done by changing the position of limbs of gas apparatus as shown 1 to 5, which figure of the correctly indicate the levels of liquid curve. Then considering given diagram, we can identify that liquid column in B is higher than liquid column in A. Then to get the same level, A should have a small height, and for the second answer, height of A is less than B, and the upper surface is at same level. Then answer 2 is correct for the question number 36. 37. Final masses of three liquids of densities D1, D2 and D3 are added together. If the liquid mix together without causing any change, then density of composite liquid will be. We can consider sum of masses should be equal to total mass. 37. We know that density equals mass divided by volume. In question number 37, it should correct not final masses of three liquids, same masses of three liquids. Densities D1, D2 and D3 are added together. Then they have given same masses. Mass density given. We have to consider the volume. Sum of volumes equals total volume. We know that density equals mass divided by volume. When subject in volume, mass divided by density. Therefore, we can get m divided by d1 plus m divided by d2 plus m divided by d3 should be equal to total mass 3m divided by resultant density d. We have to find the resultant density d. We can cancel out all m terms. We have to get the LCM. d1, d2, d3, d2, d3 plus d1, d3 plus d1, d2 equals 3 divided by d. Now we can subject d value. 3 times d1, d2, d3 divided by d2, d3 plus d1, d3 plus d1, d2. Then answer is 3 for the question number 37. Then 38. The inner sphere of a composite solid sphere object is made of a material of density d1 and the rest of the composite sphere is made of a material of density d2 as shown in the figure. The radius of the inner sphere r1 and the radius of the composite sphere r2. If the composite sphere floats fully immersed in liquid of density d3, we know that if an object is floating fully immersed in water or any other liquid, density of liquid should be equal to density of given given object. When getting density of given composite object, we can consider mass of inner sphere. I will consider it as m1 equals volume into density. Volume 4/3 pi r1 cube into density d1 For the outer object, we can use same equation. Mass of outer object should be equals to 4/3 5 d2 into. Now we have to consider the volume of outer hollow sphere, R2 cube minus R1 cube. Then we can get total, for the total object, density, resultant density. It means total mass divided by total volume. Total mass, we have to add these two masses. 4/3 5 R1 cube D1 plus 4/3 5 D2 R2 cube minus R1 cube. This is the total mass divided by total volume. 4/3 5 R2 cube. It is the density. It should be equal to the density of given liquid D. Now we can cancel out 4/3 part. We can get 4/3 as a common factor from the numerator and we can cancel out this part. Then R1 cube D1 plus, we can expand the bracket, D2 R2 cube minus D2 R1 cube should be equals to, we can get this value to the right hand side, dr2 cube. They have given that density of liquid is d3, therefore this one should be d3. Then first answer is correct answer for question number 38. Then 39. A solid cube of plastic of mass m and side length 2x, float in water with half of the side length submerged as shown in the figure. If this cube is now converted into a hollow cube of mass m with external side length 8x, the depth which is submerged in water will be. Yeah, it's the same mass, same object. Therefore, upthrust for the first situation, given situation, we can get upthrust V rho G. Immersed volume is length 2x, breadth 2x, immersed height is x for the given situation. This is the immersed volume. V rho G should be equals to new immersed new upthrust. This is the upthrust in given situation. We have to write upthrust now for the new situation. For the new situation, length 8x, breadth 8x. We have to find the immersed height. I will get it as h rho g constant. Again, I will remember the theory. There is the same mass. Therefore, if the image is floating on liquid, we can consider that there is the same upthrust. We can cancel out rho g. 2 into 2, 4 x cube equals to 8 into 8, 64, x squared h. We can cancel out x squared. 4 divided by 4, 1, 16. X over 16 is the immersed height. Fourth answer is correct answer for question number 39. Then question number 40. A cylinder contains two immersible liquids filled of height h1 and h2 as shown in the figure. If tap T at the bottom is opened at the time T equals 0, the liquids are taken out slowly at a constant volume rate the variation of the pressure P due to liquid at the point B at the bottom of the cylinder with time is best represented by. We know that the liquid with high density is in the lower layer. Therefore, when removing the liquid with high density, there is a large pressure decreasement, and by considering H2 value is a smaller value, smaller than H1, therefore the time taken to remove the liquid in bottom layer is a smaller value than the upper layer. And for the second situation, when removing liquid in upper layer, we know that density is less than bottom layer. Therefore, decreasement of pressure is a lesser value. Gradient is decreasing. Gradient is less than first one. And for the final situation, pressure of bottom surface at B should be 0. You can answer 2 for the question number 40.